you're writing, but anyway, I have somebody helping me today. Her name is Katie. She's going to be manning the questions dialog box. Katie, do you want to say hi real quick?
Yeah, good afternoon, everyone.
All right, good deal. Well, Katie is there for an express purpose. You've probably already guessed it by now. I'm going to be conducting the training today, going through the information. That questions dialog box is for you to ask questions about the material as we're going through it, and Katie is going to field those questions as we go along. If there's one and she'll answer the questions, but if one of them comes up that she can't answer or she believes it's important enough to bring to the attention of the class, she'll stop me and we'll go through that during the class time. So you have that. Use it the whole time. Questions dialog box, that's where you can get your stuff answered. Second administrative thing is a handout. There is a copy of every slide that we're going to show you this afternoon. It's right below the box that says questions, and it is in the box that says handouts. Handouts 1 of 5. If you look in that and expand that dialog box, you'll see that there is one PDF that you can download. And again, that's a copy of every slide that we're going to show you this afternoon. Please download it sometime during this presentation. As soon as the presentation is shut off, that will no longer be available. Now, if you get to the point where you forget to do that and you want one later on, or you want to send it to somebody else, just send an email to myself or Katie, and we'd be happy to send it to you at a later time. The last thing that I want to talk about as far as administration is the time it's going to take to go through this information. This class is different than any of the other classes that we present in that I don't focus that much on regulation. I do go through a part of the presentation that deals with how we got here to these filtration systems, but I'm not specifically going to be talking about requirements for, say, the truck and bus rule or the off-road diesel vehicle regulation. If you have questions related to those, we have other classes. You can attend those classes, or we can send you links to videos for classes that were recorded. Either way, that's fine, but during this class, we don't generally cover too much of that. This class does take about 2 hours or so, so we should be here till sometime between 3 and 3:30. So if you can stay the whole time, fantastic. Love it. All right, with that, let's get to the meat of the information here. This is the information that I'm going to cover this afternoon. First of all, I'll talk briefly about the regulations that got us to these filtration systems, and then I'm going to get into what these filters are, how they work, and what makes a filter. I will really quickly talk about the 2010 engine and something called selective catalytic reduction, because there's some confusion about that and what it is and what it means. By this point, I'm sure everybody is aware, at least partially, of what it is, so hopefully it'll just be a review for you at that little section. The last two sections of this class are really designed more for people who are making a selection as to what kind of filter to use and then how to take care of it. And even though the maintenance of the filter is just one section on this outline, it is a third of the course at least, and it's perhaps one of the more important parts of this course, because the institution or the introduction of a filtration system on a diesel engine has changed the paradigm for maintenance. It's created a different way of looking at maintaining trucks. So I'll go through all that, and hopefully by the time we're done, you'll have a good idea of why it's important. Let's talk about briefly the regulatory structure that brought us here. I'm going to go over the diesel particulate matter being identified as a toxic airborne contaminant. I'll talk about new engine certification, a little bit about aftermarket parts and how they're related, and then get into what are called diesel emission control strategies and the verification program. The first thing you should be aware of is the whole idea of having filters is not new. It's not something that ARB created. The filters are not something that we brought about. Filtration systems for diesel engines have been in place for more than 50 or 60 years. There's a variety of countries all over the world that have been using some form of this technology for that long. The type of filters that we have today are something that has been selected by ARB to meet a need in this state. And that need was created because diesel particulate matter was identified as something called a toxic airborne contaminant back in 1998. Now, that seems like a long time ago, and it is, but it took at least 4 to 5 years of study and research to make that determination. What a toxic airborne contaminant is and what that designation means is that this substance, whatever it happens to be, is dangerous for humans to breathe. It's a hazard to human health. That was also agreed upon by the World Health Organization because they identified diesel particulate matter as a carcinogen. And then it led to something called the Diesel Risk Reduction Plan. So the Diesel Risk Reduction Plan is a document that was created by staff at the Air Resources Board between 1998 and the year 2000. And the whole idea behind this document was to create a path for how we were going to reduce the exposure of this substance to our population in the state of California. And this document had two basic parts. The first part was to set goals, and those goals are shown on the screen. These goals were to get to a 75% reduction of diesel particulate matter in our breathable space by the year 2010. And this is measured from 1990 levels, so we took that as a base. And then by 2020, to further reduce that exposure by another 10%, so a total of 85% reduction from 1990 levels. Now, both those dates have passed, so you might be wondering, did we meet our goals? Well, the 2010 goal, yes, we did. Now, there is argument as to whether the fact we met that goal was as a result strictly of our regulation. I personally don't believe that because we had some stuff going on in the economy at that time as well that was driving a lot of diesel technology to not be used. But we did technically meet that goal. The 85% reduction by 2020, I am not aware of whether or not we even know that we met that goal yet. I know we're already into May of 2021. But I also know that the data it takes a while for the data to be gone through, cleaned up, and made sure that it is accurate. So I don't believe we've gotten there yet. I think we will have probably met that goal, but we'll see. That was half of this risk reduction plan. The other half of the risk reduction plan was a set of strategies that we were going to have used to meet these goals. The first was one that's it's both federal and state, and it's to make the newer engines cleaner in the first place. Now, the federal government certifies all new engines for sale in the United States. The ARB has a sister program for certifying engines, but truly it's more federally controlled than anything else. We work with them, and they're a sister organization or a mother organization, however you'd like to look at it, but we do have a say in what these engines can put out. But once it's certified and it can be sold anywhere in the United States. For on-road engines, certification is done by model year, and for off-road engines, it's done by tier standard. We may talk about that a little bit later on. So that was the first method we're going to do, is just clean up the stuff that's being produced. The second step, and these happen concurrently, was to clean up the fuel that was used. So some of you probably realize this, some of you don't. And that is the fact that diesel has been around for a long time. It was actually considered a waste product at one point in our history and actually thrown away or burned and just destroyed. It wasn't until we started using it regularly for compression ignition engines that it became more valuable, and it is what it is today. But the history of diesel fuel is also that it's had a high content of sulfur in the fuel because of where it comes out of the ground. Sulfur is a contaminant, and when we started to create diesel fuel or diesel oil, it wasn't something that was initially taken out. And it wasn't something that we took out because the compression ignition engines could burn it with sulfur in there. Now, the problem with sulfur is that there are two issues with it. Number one is that diesel engines don't burn sulfur very well. It actually has a tendency to combine in certain ways during the combustion process to create sulfites and sulfates and to agglomerate and form particulates. So essentially, if you have more sulfur in the fuel, you have more particulate in the exhaust. So from our perspective, getting rid of sulfur in the diesel was a no-brainer to lower the particulate matter coming from the engine. So the Air Resources Board set a standard back in the early 90s of no more than 15 parts per million. To give you some perspective, I was working at the Air Resources Board in the early 90s when this was done, and it was not uncommon to have diesel sulfur content measured at anywhere from 50,000 parts per million up to, I think the highest I ever saw was somewhere in the 100 to 300 parts per million range. So 15 parts per million or less is practically zero. That was an accomplishment, and we instituted that here in California before anybody else did. But the federal government shortly thereafter adopted the same standard. And now today, and since those adoptions happened, you have not legally been able to either produce, store, sell, or transport any form of diesel fuel that has a higher sulfur content of 15 parts per million on average. All right, so both those first two methods of meeting our goals are nationwide. The last one on this list is one we're going to spend a lot of time talking about today, because in California we decided that we were going to go one step further because of the issues that we had with the ambient air quality standards in our state. We needed to reduce it more and quicker than what these other states in the union were doing. And so what we did is we said, we're going to regulate the use of diesel fuel in engines, and we're going to make anybody that has these engines either do one of two things: either clean the engines up or reduce their use to some low level so they will not have an impact on the particulate matter in the air. So that's what that last part is. That's a whole regulatory structure: truck and bus, off-road, TRU. All the regulations are based on that last part of this plan. And every diesel regulation that we have has come from that particular method of meeting our goals. So let's talk a little bit about some of these, or do a deep dive into some of these things. The first part is new engine certification for heavy-duty diesel engines. As I said, the federal government creates standards, and they hold engine manufacturers to these standards. So every engine manufacturer has to build their engines to meet the standards that are set by the feds in order for the engine to be certified. Well, the Air Resources Board also certifies the engines. We kind of do it in conjunction to the EPA. And at one time, we actually had more stringent standards than what the feds had. So that's why it says 49 state versus California 50 state, because there was one point where if you were an engine manufacturer, you had the possibility that you had to create two different types of engines that were the exact same thing, except one had a little bit more stringent standard to it. You created one engine that was good everywhere but California, and then one that was good in California, which made it good anywhere, because our standard was more stringent. That went away for a while, and I believe, I don't know if I'm 100% correct on this, but I do believe that we're getting back to where the feds are actually going to allow us in some ways to say that the engines have to be cleaner to operate here. But we'll see. But right now it's still 50 state is it. Every time we certify an engine, we create an executive order. And an executive order is nothing more than a document that lists information about that engine itself. It will list the family name of that engine. It'll list emission standards and the emission control systems that are coming on that engine from the factory, as well as engine models and some power ratings. And I've got an example here that I want to show you, at least the top part of. This is an executive order for a Cummins engine that was produced back in the year 2007. You can see that on the middle, on that chart right there, spreadsheet kind of looking thing, you can see the model years of 2007. Right next to it says the engine family. It also says the displacement is 6.7 liters. The fuel type is diesel. The standards and procedures for the testing that was done were the diesel cycle. And the intended service class is medium heavy duty diesel. That's what MHDD stands for. And then below that, you can see all the engine model codes and all the stuff from the manufacturer. The very far right column where it says ECS and special features. ECS is short for emission control systems. And so all the acronyms that you see there are devices that were installed on this engine at the factory to control diesel emissions, not just particulate matter, but also oxides of nitrogen, hydrocarbons, carbon monoxide, and the particulate matter. So some of these may not look familiar to you, but DDI stands for direct diesel injection. So it's electronic fuel injection. ECM is electronic control module, I believe. That's the brain that runs everything. TC is turbocharger, which a lot of people don't understand. That's actually an emission control device when you look at it from a regulatory perspective. Charge air cooler is just something that goes along with the turbocharger to help make it function properly. EGR, that's an interesting one because you don't usually see EGR on this model year of engine, but that stands for exhaust gas recirculation. And then the last two I want you to pay particular attention to because OC and PTOX. OC stands for oxidation catalyst. I'm going to be talking about that a little bit later in reference to diesel particulate filters. It's important to notice on this particular executive order that this unit has an oxidation catalyst because that is actually a type of diesel particulate filter. The PTOX, though, is the highest level of particulate filter that you can make right now that Cummins put on this engine. That stands for periodic trap oxidizer. Don't worry if you don't remember any of those. If you ever take a look at an executive order like this, those acronyms will be written out in total down below in the language of the executive order itself. You can also find some of the same information on the engine. Let's say you don't want to go onto our website and download the executive order. Well, just look for the tag on your engine. This engine has, every engine, diesel engine, is required by federal law to have something called an emission control label, at least everything manufactured from 1974 and on. And that label is required to have information about this particular engine and its emission standards. So when you look at this, you can see that we'll just read the text. In the middle of the text, it says this engine conforms to 2000 US EPA and California regulations for large non-road compression ignition engines. So right there, I know that this engine was built to a 2000 model year standard because it says it right there. It's a 50-state vehicle because it says US EPA and California regulations. And the fact that it says large non-road compression ignition engine tells me this is a diesel engine. Compression ignition is the deal. That's what diesel engines are. The other style of engine is a spark ignition, and that would be a gasoline engine because they have spark plugs. I also know that this is an off-road vehicle, and this is where I want to introduce you to a little bit of nomenclature that is used between the feds and the state of California. The federal government likes to use the phrase non-road. They also like to use the phrase off-highway. In California, we use the term off-road. In my opinion, when you see those three phrases, they all mean essentially the same thing. Off-road, non-road, off-highway all mean the same thing. But this tells me that this is an engine that was built to an off-road tier standard. Two more things I want to point out to you about this, and that is the family name. It says engine family up at the top. We're going to go through the family name nomenclature, I believe, in just a minute. But that is required on every emission control label. The last thing I want to talk about is whether or not you can find this label and how to know which label is the right label. So I can't tell you this 100%, but I've looked at hundreds of these things, maybe even thousands of these things. And I will tell you that every single one that I've ever seen has the same phrase along the top. They all say important engine information. So when you see that phrase on a tag on the engine, I can pretty much guarantee that you're looking at the emission control label. Here's a little bit different one. This is one from a CAT engine, and you can see the same kind of information. It's got the same language in the middle bottom part of it where it says 2008. So you know this is a 2008 model year engine. It lists all of the emission control devices that were put on the engine. They're in bold, kind of middle left up there. They start with EM, DITC, ECM, all those, like I pointed out on the executive order. And you can also see at the very, not the very top, but near the top left, it says engine family. So it's all bolded so it's easy to see. I guess I should have pointed out first that this is the right label. One of the reasons I put this up here next to this other label is because oftentimes people get confused that the label on the bottom is their emission control label, and that's not true. I know the one at the top is because it has all that right information, but it also has the phrase I was telling you about, important engine information. In fact, it even says it in French, avis important. I hope that's right. Anyway, so you know this is the right label. What do you need to remember about these labels and the information on them? In my opinion, you need to remember first and foremost what the engine family name is, because that engine family will tell you everything you need to know about the certification of that engine. It's also very important if you have to report that vehicle to an agency like the Air Resources Board, because we ask for the engine families when you report a piece of equipment. You also should remember what the service class of that engine is. Is it on-road versus off-road or off-highway, whatever you want to say? Because that engine is certified to a particular use category or service class, you're not really supposed to be using it for something that it's not certified to be used for. And it'll also be able to tell you whether or not you have a filtration system from the factory. For on-road engines, 2007 and newer, almost all of them came with filtration systems from the factory. I said almost all because there's a 1 to 2% chance if you have an engine that old that it didn't come from the factory with a filter. And there's reasons for that I'm not going to go into right now, but it's just a very small amount of engines that were built that way. For off-road, the filtration systems really didn't appear regularly until you got to the Tier 4 final. Some of the Tier 4 interims did have filtrations and do have filtration systems, but when you got to Tier 4 final, pretty much all of them have a filtration system on it. Let's talk a little bit about aftermarket parts. So here's the deal. There is a section of the California Vehicle Code, it's section 27156, and it's also, the language is also in the Federal Clean Air Act. And these two sections, for those two bodies of law, specifically state that you're not allowed, anybody who owns an engine that has been certified by ARB and EPA, you're not allowed to modify that engine in any way, shape, or form to hurt the emissions. In fact, if you have to replace a part, you're required by those statutes to replace it with an exact duplicate of what was on the engine when it was new from the factory. Now, so anybody that has done any work on vehicles at all or had work done on any vehicles knows that that is pretty much impossible, because the amount of time engines last these days is significant enough that the parts soon become unavailable for some of these engines. And, you know, the state of California knows that. And so what we did a long time ago is we allowed for parts that were not exact duplicates to be used in place of the original factory parts, as long as they did no damage to the emissions. That's what we call an aftermarket part. And the law that we wrote was called the aftermarket parts exemption. This would allow you to let's say you had, well, I don't know what the good example is, but let's say an EGR valve went bad and you have a 20-year-old engine or a 10-year-old engine, and you go to the dealership and ask for your EGR valve, and they no longer manufacture that EGR valve, and they don't have any in stock. But what are you going to do? You have to have that for the engine to work. You go over to your Kragen or your Chuck or Sheck's or one of the Napa stores, then you ask them, and more than likely they're going to come out with a component that will fit, and it does the exact same thing, but it doesn't look exactly like the one that was on the engine. And as in California, that part has to have a certification stamp and a tag, the sticker with it, that says that it was certified by my agency to actually be used in place of the original equipment piece. There's a giant market on the internet now, but it used to be just mail order catalogs. There's a giant market out there for aftermarket parts, and you can go online right now today and you can do a web search for practically any vehicle ever manufactured and any component that's ever been manufactured, and you can buy two types of components. You'll buy one that can be used in California and one that cannot. And a lot of the web pages, if they're doing it legally, they will actually tell you that they can't ship it to California. And the precise reason for that is this that you're looking at right now, because that component was not certified by ARB to be used as a replacement. Now, you may wonder why I'm bringing this up, because this has been a problem. We do, whenever a component gets one of these aftermarket parts exemptions, we create an executive order at the Air Resources Board for that component. And it's specifically so that that component can be sold as a replacement in California. We give it the executive order, we give it a part number, the order number's right there, and we list exactly what it's supposed to be used for. There are a lot of people out there that are in the business of selling engine components that have used this executive order as a mechanism for selling parts that are not actually legal to sell for what they're selling them for. So you have to be aware that if somebody comes up to you and says, I've got this thing that I can sell you that you can put on your vehicle and it removes all the particulates. It's not a filter, but it removes all the particulates. Here, I've got my executive order from ARB. They probably have an aftermarket parts exemption, and that's what they're showing you. But the filtration systems are not legally allowed to be sold as the type of filter you have to have in California with this type of exemption. And the biggest way you can tell which one you have looking at an executive order is by the fact that an executive order for an aftermarket parts exemption is the number is going to start with a D, just a large D. So if you see that, read a little bit closer. What you're looking at is an aftermarket parts exemption. There's an interesting case right here. The company Bosthart Engineering, which I'm not even sure they're still in business, they wanted to sell DPFs, diesel particulate filters, as retrofits in the state of California. And in order to do that, they have to go through another process, which I'll talk about in just a second, called verification. They had this particular Econics unit in that process, but it wasn't done being in that process. And they wanted to sell this unit, and they couldn't sell it as an actual DPF. But what they did is they got an aftermarket parts exemption because this thing does no damage to emissions. It actually cleaned the emissions, and they were able to sell it as an aftermarket part before they actually got verification to sell it as a filter. That's why on this unit you can see the CARB EO number says D-690. D means that it's aftermarket parts. Now, if you want a filtration system that meets the standard for actually reducing emissions from a diesel engine, that unit has to go through another process, not the aftermarket process. It goes through a verification process. Again, this is something that's run by my agency. We have a whole group that does nothing but run through verifications. And what they do is they take information on a component that some dealer, some manufacturer wants to sell, and in order to be able to sell that as a diesel emission control strategy, which is a level higher than an aftermarket part, they have to prove that it actually does several things. They have to quantify the performance, which means the emission reductions that they're suggesting these components have is real and that it will stay real. It's a durable unit. It has to be verified to a particular engine model, year or tier or engine family, and it has to be unique for each service type. So you have to have a different verification for on-road versus off-road versus stationary, so on and so forth. But all aftermarket parts, all retrofit filters had to go through this verification process before they were legal to sell in the state of California and legal to install on any diesel engine. This diesel emission control strategy verification process makes sure that whatever claims they're making about this device are real and that they will be, they provide reductions that comply with the regulation. It's different than aftermarket parts. So if you get a DEX verification, you have a standard much higher than an aftermarket parts. Remember the aftermarket parts, I said the only level of proof you have to have there is that it doesn't damage the emissions. A verification actually reduces emissions. That's what it's saying. And a verification will also provide a warranty, an emissions-related warranty. Speaking of warranties, I wanted to give you some idea of what the minimum warranty periods are currently for a variety of things. If you're looking at on-road engines versus off-road engines, and these are emission components, the range for the horsepower ratings are going to be anywhere from 5 years up to 150,000 miles or 5 years up to 4,200 hours. So you have a substantial warranty that the manufacturers are required to provide for any emission-related component. And that would also, that includes verified products. So if you look at the executive order for one of these units, these verified filters, it looks a lot like the aftermarket parts executive order. We didn't really differentiate it much. But if you want to know that you have one that's actually been verified, look for DE in the name rather than just D. It'll say down below in the actual text. But if you just want a quick and dirty, yeah, this is a verified filter versus an aftermarket parts, that's the easy way to tell. Now, whenever a emission control strategy goes through a verification, one of the requirements is that a family name for that unit is created. This is the same kind of idea as with the engine families, except this is just for the part, not the engine itself. And here's a example of the information that's included in a DEX family name. I'll just give you the idea there, but let's take a look at a real one. Here you've got a pure filter device that was manufactured back in, what this date here, 2003. You can see that by the family name, it was manufactured for California. ECS is the manufacturer's name. That's the company called Emission Control Systems. It was manufactured for the 2003. That's when it was actually verified. PM3 is the level of control this device does. I'll talk more in just a few minutes about different levels of filtration systems, but PM3 is the highest level that you can get. N00 in the family name is telling you that there's zero NOx control. Some of these devices not only would control particulate matter, but they also had the ability to lower the NOx coming from the engine. ON is the service class. So this is designed for on-road use. And then the last area there, DPF 02, that's where ECS gets to put in the model name of this particular unit. Now, one thing I'm not going to talk about beyond the slide, but I put it on here because I do need to bring it up. You're all looking at the side of a diesel particulate filter that was installed as a retrofit. That's why these labels are on them. But you're also looking at the flow label, and I'm sure some of you are wondering why there's a flow label on this. Well, that's to show the direction that the exhaust is supposed to go through this particular core. The reason that's there is because in early verification process, we didn't actually specify that there had to be a flow direction. And so what would happen is the manufacturers were making these cores that could actually be flipped around. And the problem with that is that that's how they would clean them out. The filter collected all the soot, they would turn them around, and then the soot would be blown out the exhaust. So we didn't want that to happen anymore. So we required them to build these things so they could only go in one, the air could only go in one direction. And we also required the flow diagram chart to be there. So that's why you see that there. Okay. On any retrofitted vehicle, the retrofit has to have that label I just showed you on it, but there has to be a matching label, or there's supposed to be legally a matching label somewhere else on the engine. And the purpose of this is so that somebody from an agency like the Air Resources Board could inspect this without having to get underneath the thing and look at it. This is supposed to have the same information as to what filter has been installed on that. I will tell you that this tag, even though that's legally required, my guess is that most trucks with retrofits don't actually have this tag. Or if they did at one time, it's not there anymore. I just had a lot of people that have come to me and they were surprised when I told them this is supposed to be there. All right, enough about the laws. Let's talk about what the heck these things are. So what is a diesel particulate filter and how does it work? That's the section we're in right now. We're going to talk about the types of control units, how they're built, and how they're cleaned. There are three basic levels of filtration when you're talking about a verified diesel particulate filter. And some of these, like I said, have been around for decades. Some of them are relatively new. The first two levels have been around for decades. The first one has been around longer than anything. And it's called a level 1 device, and this is also where the phrase diesel oxidation catalyst comes in, because that's what this thing is. Now, the way this thing works is it's exactly like the catalytic converter that you have on all of your regular automobiles. They are typically going to be constructed of a ceramic material that is built in a honeycomb fashion. You can see the picture right there that shows that honeycomb style there. What that means is that the ceramic it's like coffee cup material, and it's got a bunch of holes in it, and those holes are basically channels that the exhaust passes through. Now the channels go from one end of the ceramic unit to the other end, and inside those channels, the ceramic has been impregnated with a variety of precious metals and other catalytic materials that allow the exhaust gases to go through reactions that they wouldn't go through otherwise. And the reactions that we're talking about are to oxidize and reduce pollutants coming from the engine, so that when the final exhaust comes out, it's basically close to perfect as far as we can get. These are made of monolith ceramic, and with regards to diesel particulate matter, their efficiency is anywhere from 25 to 49%. Now what that means is that of all the particulate matter coming from the engine that goes through a level 1 device, a minimum of 25% of it will be destroyed, oxidized, and a maximum of 49% will be oxidized. I can tell you from my experience that once these things get put into use, they don't reach that 49%, but they do oxidize a fair amount still, and that's why they are used as in conjunction with other filtration systems to make the whole system work better. If you remember the executive order that I showed you earlier, it had OC and PTOX on it. Well, OC is the level 1 filter, and then right after that it had a periodic trap oxidizer, so they put them in to work in conjunction with each other. All right, well, that's a level 1 device. Level 2 devices are still what we call pass-through devices, which means that there's nothing that physically blocks the exhaust gases from passing through them. It's just that the level 1 device has nothing. It just lets the gases go straight through, no back pressure, no anything. Level 2 devices, if I had to describe this in a way that would make sense to most people, I would say if you took the same canister that the filter is in and you packed it with steel wool, you still have the ability for the exhaust gases to pass through unimpeded for the most part, but instead of going straight through like they do in the level 1 filter, they have to make turns and go backwards and up and down and around because they're having to get through the steel wool. What that does is it slows the particulates down as they go through, and it actually provides more impact space for the particulates to be dropping out of the exhaust flow before they get to the other end. That's why these devices can actually control anywhere from 50% up to 84% of the diesel particulate soot coming from an engine. But even though that's pretty high, it's still not high enough for our regulatory purposes. So in California, for a long time, we have required nothing less than a level 3 device. And a level 3 device is called also a wall flow filter. Now, this is the first time we've had a filter that wasn't pass-through. So if you were to look at this filter, and I've got a cutaway of it right there, you can see that it has channels. Now, those channels are a lot like and they're built very much the same way as the level 1 device. So still picture that honeycomb with all those channels in it. The biggest difference, there's two big differences, is number one, that 50% of the channels on either end are plugged. So on one end, on the intake side, there are open plug, open plug, open plug. The exhaust gases are going to go into the open ones because the plugs are impermeable. They don't allow gases to pass through. The exhaust gases go through that channel, and when they get to the end of that channel, there's a plug on the other end. So they can't go anywhere. But that's where the other interesting part of this filter is because the sidewall of these channels is also made of ceramic, but it's been put through an aeration process that creates a ton of tiny little pores. You can see right above the image of that filter on the bottom right, there is something that looks like a sponge. That's a blow-up of the core material in the sidewalls. See how many thousands of holes are looking right there. It looks solid when you look at it, but actually it is filled with holes. The thing about it is those holes are extremely small, and they're small enough so that they will only let gaseous material pass through, but not solid material. So what is diesel particulate matter? That is a solid material. It's dust, basically. So all the dust and the exhaust gases go into the open channel. They get stopped by the plug at the other end. And then all the exhaust gases, which are small enough and tiny enough to pass through, will actually go through. God, who's doing that? I got to get rid of that. I thought I turned that off. Okay, Katie, I don't know how that's happening.
The away message has been overriding on Teams lately, so you might have to close out of the whole application.
I'm going to mute that discussion, and I'm going to close out of it. Just for those of you in the audience that don't know what's going on, our office runs our communication system through Microsoft Teams. And Microsoft Teams, while it's a fantastic piece of software, is kind of obtrusive sometimes when we're doing these presentations, because it'll give us notifications like that when we're not really wanting them. There is a function to turn it to do not disturb, but apparently it's not working properly. Kind of an interesting sidebar. I understand Microsoft is being waylaid and under attack by hackers in different parts of the world, so they're having trouble with their systems. Anyway, let's finish this discussion. The sidewalls. That picture shows you the pores, and when the exhaust gases go in, the diesel particulate is trapped because it can't go through those pores, but all the exhaust gases, the air, the NOx, the carbon monoxide, the carbon dioxide, anything in the gaseous state is passing right through and goes out the other end, because the gases are passing into the channels that are next to this one with the plug on the end, because they don't have a plug on the end. That's the way these things are designed. Anyway, all that particulate matter is trapped, which is why you may have in the past heard the term trap associated with a diesel particulate filter, because it's trapping all the soot. That trapping creates a problem. What do you do with the soot once you've trapped so much of it? Just a little bit more on the wall flow filter functionality. These images here are just to give you a better idea of what I'm talking about, so we don't need to go through that because I did a bunch of that already. But let's talk about what we do with the soot. So I want you to picture something in your mind's eye. I want you to picture you holding a handful of soot that came from a diesel engine. I mean, a big old chunk, like a tablespoon or two. And I want you to picture yourself crushing that to the level where it all sticks together. What are you making? Well, hopefully you guys have a really good ability of picturing those things, but you're making a diesel or a charcoal briquette, or something that resembles a charcoal briquette. The reason I'm using that analogy is because diesel particulate matter and charcoal are both raw carbon, and on a molecular scale they are extremely similar. They're both very similar. How do we get rid of charcoal? Well, we burn it. That's how you make barbecues, right? Well, diesel soot is the same thing. It's very, very, very similar to charcoal. So when we want to clean these filters out, because you can't have the filter plugged with this stuff, it's got to be gotten out somehow, we burn it. That means you've got to get the filter hot enough in some way that that charcoal will burn up. This process is called regeneration, because you're regenerating the filter's ability to collect more soot. And the process can occur at different temperatures. Let's take a look at what those temperatures are. So if you were to look at just nothing more than burning it with a flame, just with oxygen, O2, you have to get that temperature up to 1,000 degrees Fahrenheit or more in order to combust that carbon material. Then what you're trying to do is create a reaction. Fire is nothing more than a chemical reaction. It converts solids into gases. And the gases that we're trying to convert the soot into is CO2. We're using O2 and the raw carbon and combining them with heat to create CO2, which is then a gas that can pass through the sidewalls and get out the other side. Well, here's the problem, okay? 1,000 degrees is really hot. And we're talking about something that's going to be in the exhaust train of a vehicle. Very rarely do you have, in fact, I can't think of one, do you have an exhaust that is going to reach 1,000 degrees Fahrenheit? If you did, we'd have major problems with exhaust systems. So that's not really workable. We need to lower that temperature. And there's been a couple of ideas. The first idea that came out was using something called a fuel-borne catalyst, FBC. And that catalyst did a good job. It was able to reduce the combustion temperature necessary in the exhaust to 850 degrees Fahrenheit, which, that's significant, but it's still not low enough to allow this to happen in a standard or regular exhaust system. So some brilliant person came up with the idea of using something that's in the exhaust already, or could be in the exhaust already, and that's nitrogen dioxide. If you have diesel soot in the presence of nitrogen dioxide in the exhaust, all you have to do, that's actually a catalyst, all you have to do is have a temperature of 480 degrees Fahrenheit or higher in order for that reaction to take place and for the soot to be burned up. All right? Now, 480 degrees is very doable in a lot of exhaust systems. It's hot still, but it's very doable. So that is the goal if you want to do this properly. That's why we have different ways of regenerating these devices, and we give them new names. The first way is something called passive. Well, passive regeneration means that we're going to burn the soot off without adding any additional energy to the system than what's naturally produced by the engine itself. We're going to be able to get to whatever the temperature we need is just based on how the engine works. We also have active, where the way the engine's used, its duty cycle is not conducive to producing the temperatures, so we have to do something to bring the temperature up. That means we're going to add energy to the system in order for the regeneration to take place. Finally, you have systems that use both strategies, and they're called hybrids. And I'll probably say this again later on, but any filter that comes from the factory on an engine as an OEM part, OEM stands for Original Equipment Manufacturer, and these are things that are built on the engine. Any one of these diesel particulate filters that comes from the factory on these engines is a hybrid system. And the reason it's hybrid is because the manufacturer does not know how the end product is going to be used. They don't know if you're going to have a hot running system or a cool running system. So they're selling you a vehicle that has to work in both situations. Therefore, they're going to give you a device that is capable of working whether or not you have the temperatures necessary to do it. So that's why they install these hybrid systems. I've mentioned the word duty cycle, or the phrase duty cycle, a couple of times. So let's discuss what that is, because that's where this temperature stuff comes from. Your duty cycle is nothing more than the engine cycle, or the heat profile of the engine as the vehicle is in use. So when you turn an engine on, whether it's off-road or on-road or stationary, it's a cold engine. It's initially going to go through a warm-up period. Its temperature is going to be very low. Then when you put the engine under load, so for an on-road engine, that means putting the vehicle in gear, driving it around, or an off-road engine. For a stationary engine, that probably means putting it under some kind of gearing system that uses the rotational force of the energy and increases the resistance on the energy. You're going to raise the temperature as that engine heats up. And there will be variations depending on how you use this engine. So for an off-road, on-road engine, you'll see the temperatures rise as you're putting more load on it. The temperatures will go down as you're dropping that load. Say you're in an idle state, and then they'll go back up as you put more load on the engine. And then when you go to that final part where you're going to stop using the engine and you park it, you're going to a lower temperature state there. So on this chart, what I've done here is to show you not a typical duty cycle. This is a made-up one, but you've got 200 degrees as the bottom line, 750 is the top line, and then the magic number is 480. We need the temperature to get to 480 for regeneration to take place naturally. So when we look at the duty cycle of an engine, we want to measure the temperature over time as it's being used. As long as that temperature is below 480, we are producing more soot. We're capturing more soot than we're burning, because that is below the 480. And I just went through telling you the soot doesn't burn until it gets that temperature. When we're at 480 as the exhaust temperature, we're actually burning the soot as fast as we're producing it. We're at a steady state. Anytime we go above 480, we're actually burning the soot faster than we produce it. So we're cleaning this thing out before it can load. Whenever we are looking to determine what kind of filter belongs on a particular engine, we have to look at the duty cycle to make that determination. So let's go through these regeneration methods a little bit more closely. Passive regeneration, as I said earlier, is the ability to clean these filters out using only the exhaust temperatures. And these are going to use that nitrogen dioxide, that catalytic reaction, around 480 degrees. Now, we have to have enough of that nitrogen dioxide to make this work properly, and nitrogen dioxide is not actually something that you get a lot of in diesel exhaust. You do get nitrogen oxide, which is just a single oxygen atom on that molecule, but you don't get nitrogen dioxide. And in order for this to work, we have to have nitrogen dioxide. So how do you do that? Well, we use that by having diesel oxidation catalysts and catalyzed filters that the exhaust goes through before it gets to where the soot is collected and regenerated. Let's take a look at this here. You can see both of these are representations of engines. You've got the engine with its gas tank on the left, and then the exhaust is going into the filter. On the first one on the left, you have a diesel oxidation catalyst that the gases pass through before they get to the filter represented here by the channeled area, right? And what that DOC is doing is it's doing two things actually. It's destroying some of the soot. Remember, diesel oxidation catalysts can reduce soot by about 25 to 49%. So it is actually destroying some of the soot in that device just because it's there. But it's also taking nitrogen oxide and converting it to nitrogen dioxide, which is then used in the other part of the filter to reduce and regenerate the soot. There's a different way of doing it, and that's the example on the right here. We don't have a diesel oxidation catalyst that's a separate unit. The red designation on the filtered area is telling you that that's where we put the catalyst material. So when the exhaust gases come into this, they go right into the filter collection area, the soot collection area, and because there are catalytic materials present, the conversion of the nitrogen oxide to nitrogen dioxide and the destruction of the particulate matter all happen at the same time in the same place. It's a little bit more efficient, and it happens all together. DOCs, as I said earlier, they can influence chemical reaction, but they don't get consumed. They have catalytic materials impregnated on them. Precious metals are the typical ones: platinum, palladium, rhodium. These are all things that are in catalytic materials. They use oxygen across that catalyst to promote the reaction. And they oxidize, in most exhaust systems, carbon monoxide into carbon dioxide. They will oxidize hydrocarbons into water and carbon dioxide. And then PM and NO are going to be oxidized into water, carbon dioxide, and nitrogen dioxide. Here's an example of a diesel particulate filter that has all these components to it. This is a Johnson Matthey CRT, which is a passive device. You can see the inlet. That's where the exhaust gases are coming in from the engine. The very first thing that the exhaust gases meet is something called a diffuser, and that is nothing more than a plate with a bunch of holes in it, and its purpose is to spread the exhaust out. Because if you had the exhaust coming in at a single point, it would tend to do a burnout on the center of that catalyst. That catalyst is the DOC, the diesel oxidation catalyst. And I've already explained what that does, but it's allowing that NO2 to be formed, and then in the actual filter component of this, the wall flow filter, you get the destruction of all the soot and clean gases coming out the outlet. All right, so that's passive regeneration. Let's spend a little bit of time talking about active regeneration. If you remember, I said that there are some duty cycles that do not lend themselves to producing the temperatures necessary for this reaction to take place. So these kind of duty cycles would be a lot of stop and go. So your delivery vans are a perfect example. They're going to drive a little ways, stop, then drive a little ways, stop, drive a little. So they never give the engine an opportunity to really heat up to the temperature necessary to use as a passive device. So they have to have some type of added energy in order to oxidize that soot at that higher level. There's two different varieties of these. They would be used depending on the type where they get the energy from. So some of them use electricity and some of them use fuel. The electrical ones oftentimes are going to have an actual elemental heater inside. That picture on the right shows the heating element, and anybody that has an old electric stove that has that coil on it knows exactly what that is. It's a resistor coil. When you pass electricity through a resistor coil, it's resisting the flow of that electricity, which causes it to heat up. So this is a commercial version. It actually would heat up to 1,000 degrees Fahrenheit, and there's a little fan behind there, and inside the filter, that heat is being blown across the filter to burn the soot off. This is something that cannot be done while the vehicle is in action. It has to be done when the vehicle is offline, because the electricity necessary for this, the amperage necessary for this, is much more than any engine can produce. You wipe out all the batteries, so you can't do it while the vehicle is being used. This would be perfect for vehicles that are driven during the day and the soot's being collected on the filter, and then they're parked at a yard during the night, and overnight this takes place. So 45 minutes is the minimum time it usually takes to run one of these things, but oftentimes it'll just run overnight. Here's an example of an installation where you've got the buses. These are, muni buses, and they've got these kind of filters, and you can see that this one is at a yard and it's plugged in. While it's plugged in, there's two plugs. One of them is providing airflow, and the other one is providing the actual electricity. I put a picture on the right here as well to show you the infrastructure that is necessary to do this. So that box had to be installed specifically to meter the amount of electricity going into the control system, as well as to provide the right voltages and amperages for this device. There are portable units. We like to call them R2D2 units, where you can take them out into a yard and still perform the same function that the installed one does. All right, that was the electrical one. Now we have to talk about ones that use fuel, active fuel dosing. These are ones that will use fuel that's in the vehicle's fueling system and uses a blower for fresh air, but essentially it burns some of the same fuel to create the heat that causes the regeneration to take place. The picture on the bottom shows a device, a diesel particulate filter manufactured by a company called Hoos. There's one of the top-end type filters, but they have a flame that is inside their unit, and when the thing is offline, that flame comes on and basically burns all the soot off using that flame. The more common one is shown here. This is an active fuel dosing. If you were to ask me which is going to be the more common style for most OEM type installations, it would be this one right here. Because what you have is an engine running, diesel engine. You've got a filter that is collecting the soot, and then periodically you're going to have a dose of fuel, the raw fuel that goes into the exhaust after the engine, and it comes into contact with the very first part of the filter, which is the diesel oxidation catalyst. Now, this is raw fuel, and when raw fuel comes in contact with the catalyst, raw fuel is nothing more than a hydrocarbon. Catalysts will tend to allow that to react. It'll create its own little flame, its own little heater, and that will burn the rest of the filter off. This is the only fuel dosing one that you can, the only active variety that you can have where the engine itself and the vehicle can be running down the road while regeneration is happening. That's why I said most of your OEM units that I've seen are going to have something like this. Now that fuel dosing unit as well, that one is after the combustion process, but the newer units today actually use the electronic fuel injection system as the dosing unit as well. What they do is just have an event in the electronic fuel dispenser to throw in some fuel after the combustion has already taken place. It accomplishes the same thing as this does, just inside the actual core of the engine rather than just being in the exhaust. Right, I wanted to give you a little bit of a comparison between these two. So your passive systems use engine exhaust, while the active ones actually have to have additional heat added. Your passive systems are really dependent on duty cycles, so you can't really use this in any vehicle that's going to have a colder running duty cycle like stop and go. Active systems, that doesn't really matter what the duty cycle is because you've got that energy that you're going to add anyway. Passive systems always use catalysts. They have to. They have to have that NO2, so the catalysts have to be there. And the active ones, there's a lot more variation because they're more flexible in using different methods, so they don't necessarily have to have catalysts. Hybrid regeneration just does both. You can see in this diagram here, you've got the engine just like we did before, you've got the filter just like we did before, but the representation is here. As you see the wall flow filter is red, so in a previous diagram that I showed you, I said that designated that catalytic materials were actually on the filter core itself. So we've got the ability to do a passive regeneration because we've got catalytic materials there, but then you see a flame, so this one has both. It could use active or passive. Let's take a quick look at some of these. Now, normally if we were in a classroom, which I hope to be at some point nearer rather than later in the future, I know Katie does as well, we would hand this out and we'd have you try and write and see what your guesses were. But since we're online, I'm going to have to go through these and just tell you what they are. Here's a system. I want you to look at it and see if you can tell whether this is active or passive and how well or how this regenerates itself. Well, this is kind of one like we've seen before. That red lined rectangle represents a diesel oxidation catalyst, and the filter itself doesn't have any catalytic material. So this is a passive system that's using a separate diesel oxidation catalyst, or DOC, to provide that oxidation and build up that NO2 so that the regeneration can happen in the core of the filter. Here's the other half of that. This is also a passive system. We just don't have a DOC because the filter core itself, the wall flow material, has the catalyst on it so that the exhaust gases, the particulate matter, the NO2, and everything are all being catalyzed at the same time in the same place. Here's one that has no catalyst materials as far as we can tell. There's no red in anywhere in there. And it has a flame. So this is a direct flame active filter. All right, this is a little bit different. We've got the red, but it's a squiggly line rather than a straight line. And if you follow the line up, you can see that it actually has the designation for a switch and a plug. So this is a plug-in electric. This is going to be an active system that has to plug in order to regenerate. And here, what do we got? Here we've got a flame, and we've got the wall flow filter with catalytic material. I showed you this one already. This is a hybrid system because it can use both methods to regenerate. This one can too, because we've got the catalytic core. We also have the plug-in, so this one will do both as well. All right, so that's filters and how they work. I wanted to, just for a few minutes, talk about the 2010 engine and what it represents. So a lot of our regulations, well, on-road regulations, require anybody driving a diesel vehicle in the state of California to, sometime in the very near future, drive nothing less than a vehicle that has a 2010 or newer model year engine. And there's been some confusion as to exactly what that means. So here's the diagram for it. You can see the engine on the far left is producing a soot. That exhaust goes through the very first control device, which is the diesel particulate filter. And that unit is designed to do nothing but get rid of particulate matter. It doesn't have any other function. That's its sole purpose. So it filters out all of the soot. When you get through that device, you still have exhaust that's going to have oxides of nitrogen in it, though, because that's one of the things that diesel engines tend to produce. And so all 2010 engines, well, like most 2010 engines, are actually going to have a secondary catalytic system in the exhaust stream that comes after the filtration device, the DPF. And in that secondary exhaust system, it is a catalyst that uses a very special catalytic material in that it only does what it's supposed to do in the presence of pure ammonia. If anybody in this audience has ever smelled pure ammonia, you know that that's something, because that's what smelling salts are. It's actually very dangerous in very low concentrations. It'll burn your sinuses, it'll burn everything. But we have to have pure ammonia in order for this to work. This is a selective catalytic reduction system in that it takes the oxides of nitrogen, both NO and NO2, and NO3 that are coming through the exhaust after the filtration system, and it converts them into nitrogen gas, water, and CO2. So it has to have pure ammonia, but the problem is that ammonia is dangerous, and we cannot require people to carry ammonia either in a aqueous state or in a powdered state. It'd just be too dangerous because it's a dangerous chemical. So how do we get it? Well, that's where the diesel exhaust fluid comes in, because diesel exhaust fluid is actually something that is very safe. You could actually drink it and it won't kill you. You have a sore stomach, but it won't kill you. And you spritz a little bit of that in the exhaust between the diesel particulate filter and the SCR catalyst, and just the temperature of the exhaust at that point will convert most of that DEF fluid into ammonia, which is then used by the catalyst to perform its function and reduce the NOx. Very beautiful way the system works as long as it's working properly. There are a couple of issues with it. The first issue would be, not always is all the ammonia utilized by the SCR. It's temperature dependent, extremely temperature dependent. So if the filter is not at the right temperature, if the catalyst is not at the right temperature, it will have a tendency to allow that ammonia to slip past, and you may get an ammonia smell in the air around one of these devices where that's happening, one of these trucks. The other thing that can happen is that when the filter itself is going through a major regeneration, it will have a tendency to heat the exhaust in that comes after it to the point where it flash steams the diesel exhaust fluid in the exhaust, and that can create a problem with the secondary unit's control system. So that's why you have a warning light in most diesel engines now that have this system. They can tell you that there's a higher than normal exhaust temperature. That's usually an indicator that the filtration system is going through regeneration. All right. Here's another SCR system, just to give you some basics. You've got NO, which is nitrogen oxide, oxygen, that's the O2, and then NO2 in the exhaust that came from the filtration system. You notice there's no particulate matter there. We're spritzing in a little bit of the diesel exhaust fluid, and it gives you the chemical formulation there for it. It goes into the SCR catalyst, and what comes out the other end is nitrogen gas, water, and CO2. Here's an industrial version of it. Just to give you an idea of what the actual reaction is, the same catalytic process is going on here. I only put this on here to show you the actual formulation. The formula on the bottom right-hand side is boxed, and it's in a white shade instead of having the blue shade on it. So you can see what the actual formula is for this reaction. SCRs do have issues. They're very sensitive to contamination and plugging. The catalytic material can also be easily poisoned if you happen to have some bad fuel or you put the wrong kind of fuel in. They can cause, as I was mentioning earlier, excessive ammonia slip. That's the stinky smell that comes out the exhaust for some of these things when this SCR is not operating properly. And then they are extremely temperature dependent, so your startups of the vehicle and the regeneration of the DPF will have a tendency to negatively affect their ability to control the NOx. All right, so we've gone through what a filter is, how it works, all the plans and regulations that got them here, and now we're at the point where we need to talk about how do you know you have the right one for your particular engine? So I'm going to show you the research pages that we have available for you and talk about installation and choosing installers. Now, I'm going to preface this by saying that this is for retrofits, and I know we're to the point now where there aren't that many retrofits being installed on on-road engines. We're past the point where practically any of them should be installed on on-road engines. But we're now going to be getting into off-road engines as well, and stationary and portable, and all those have the possibility of having these things installed. So this is still something that is useful. We do have an install page for diesel emission control systems. There is the link. If you go to that page and click on it, well, actually just go to ARB's main homepage, click on diesel activities, and then click on diesel exhaust retrofits. It should take you right to that page. We also have the truck stop, which is a separate page that is a little bit easier to navigate, in my opinion. You can go to help and resources and then select PM filter information to get to the same page. What you're going to find here is a little bit of history, an overview, including some videos of a variety of installations. There will be a list of manufacturer-approved installers, some guidelines on maintaining, some advisories and FAQs that are associated with filters, and then a list of the currently verified retrofits. Here's what the DEX page looks like today, and I've outlined how to find and install DPFs, because if you go there, it's going to take you here, and this is basically all you need if you want to do your research before you actually utilize the process of putting one of these filters on, because it will give you an idea of what information you need. And it's all lined up here. Know the engine model, year, and family name, identify the technology that's compatible with that engine, selecting the right DPF, then finding somebody who can install it, and the things you have to do before you do install it. So we'll go to the currently verified devices. This is going to give you a list of all the units that have been verified by ARB. And on this list, you should have actually two lists, maybe three. I don't think there's a level 1 list, but there's at least two lists, one for level 2 filters and one for level 3. If you're trying to comply with any of our current regulation, you can't use a level 2 filter. It has to be a level 3 filter, so you should stay on that page. And this page will give you a product name, which is actually a link to the documents associated with that particular unit. It tells you what type of technology it is, what its particulate matter reduction level is. They should all say 85%, and whether or not it has any reduction of oxides of nitrogen. And finally, in the far right-hand column, it'll tell you which engines and duty cycles it's applicable to. One final thing before I leave this page, I've highlighted the clear information page. This should not be that much of a problem at this point, but it is somewhat of a problem because I have actually had a couple of calls about this recently. But Clear was one of the early manufacturers of filters that came on when our regulations were brand new. And they're a company that was a combination of Cummins and CAT, and they created a company specifically to build filtration systems to meet the retrofit requirements of the Air Resources Board regulations. Problem is that they created a filter, and it was called the Clear Long Mile, that actually, even though it was probably one of the best filters made, had some problems in that it overheated, and it actually caused several fires and the loss of a lot of damage, or a lot of property. So that unit was de-verified by the Air Resources Board, which essentially meant that anybody that had one of these things on their vehicle was automatically out of compliance because the unit was no longer verified. We've spent thousands of hours and tens of thousands, perhaps millions of dollars at my agency trying to correct this problem, because a large majority of the Clear long mile filters that were installed were put on school buses. And so we've gone through the process of replacing practically all of them. But there's still some out there, and if you have questions, we've created a separate page just for that. Right, if you don't want to go to that list and try and find something that works for you, there is a database that you can do a keyword search on, or a search on, It gives you the ability to pick things from drop-down menus. You can browse by the emission control system. You can browse by the executive order if you have that number. You can browse by family name. As long as you have it, you can put it in there. Or you can browse by engine year, engine manufacturer, and displacement. This can be a very useful tool for getting a list of filters that would qualify for any engine that you have. Once you decide that you need a filter, or whatever engine we're talking about, before it's going to be allowed to be installed, there has to be some type of check to see that it will even work on the engine. And that's called a pre-installation compatibility check, or PIC. So this is an engine and platform assessment. What happens is you take a look at the engine and see what kind of condition it's in, because if the engine is not well maintained to begin with, most filter manufacturers will not even sell you a filter to go on that thing. It is required as an, I should actually put the date. It says October 1st, but that's got to be October 1st, like 2014 or something like that. And the test will, the compatibility check will look for opacity tests, fuel injection systems, turbocharger condition, excessive oil consumption, and how often and how well you tune the engine. Your executive order will also list some specific conditions for the filter that will tell you what family names it's been approved for, what model, a year range of engines, what kind of cycle it should be used on, and if there's any additional allowed existing control system. When we were talking about the executive order, I brought up the fact that a lot of engines that have filtration systems from the factory don't also have exhaust gas recirculation systems, or EGR. That's because they're not typically compatible. The exhaust gas recirculation system has a tendency to lower the exhaust of the overall engine, which is a problem for filters because filters like to run hot. The executive order for the filter will also tell you whether or not any fuel additives are legal to run with that vehicle when it's got that filter on it, as well as if you're able to use any significant amount of biodiesel. All right, so one of the things that has to happen, but not for every pre-installation, is something called data logging. And all this is a way to figure out whether or not your particular engine's normal duty cycle is compatible with a passive system versus an active system. So it's only required if you're trying to put a passive filter on there. And you may be wondering, well, why do I want just a passive filter? Well, passive filters are less expensive if you're looking into retrofits than active systems, because there's just not that much on them, comparatively speaking. They don't have the extra heating elements or the extra fuel dosers. So this is the whole data logging unit that will be used. You can see that it's got a probe and it's got a wire for plugging in, and it also has a computer chip. That's the computer chip. There's the probe that goes in the exhaust about where the new filter is going to be, and there's the plug for power. This has to be installed for 24 hours of actual operation. That's not clock time, that's use of the vehicle. So you're getting 24 hours of use, and that's hopefully it's a representative duty cycle. We would prefer that that you spend more time and make sure that you got the right duty cycle, because if you change the way you drive the truck just to qualify for a passive filter and then you use the truck in a different manner, you're not going to have fun with this passive filter. It'll plug up most of the time. This is the data that we get out of the unit, though. This gives us temperature spikes over time. There's several ways to look at it. That's one type of chart. This is the one that we probably use more, though, because it tells you how often, what percentage of the time this engine spends at a variety of temperatures, all the way up to, what is the highest one, 380 degrees or something like that. So this engine is probably not a good candidate for a passive system. Because actually, I'm looking at that wrong, because it's Celsius. So that's a lot higher number when you're talking about Fahrenheit, when you convert it to Fahrenheit. So I'm going to retract that. This probably would be a good candidate for a passive system.
Randy, you do have a question.
Okay.
Would the installation of a hybrid device on an off-road engine change the current tier of the engine?
No, you don't change. So tiers are a combination of the model year the engine was constructed versus the horsepower rating or horsepower category of the engine. It's something that you cannot change unless you repower the engine entirely, because just adding a filter, all that does is reduce the exhaust contaminants. It does not change any of the other components on the engine that went into building the next tier. So again, you'd have to repower, not just install a filter. Was that it, Katie?
Yes, thank you.
Okay. All right, so let's talk about when you get to the point where you need to find someone to install this device, because I don't want you to think that you can just do it yourself. In most cases, that's not true. Now, it is possible that you could do your own installations here, but in order for it to be legal and correct, you need to be certified by the manufacturer of the filter you're installing to be able to install their filter. And you have to be approved by the manufacturer. Now, being approved by the manufacturer just means you've gone through their school. ARB, my agency, does not approve any installers for any filtration systems. We leave that up to the manufacturer. But we do have lists that the manufacturers have given us that we post on our page for anybody that wants to take a look at the current list. This is under how to find and install DPFs on the main page. It'll take you to this list, which you saw earlier, and number 4 on the step is finding an installer. You click on that, it takes you to this section where it tells you about how to find an installer and whether or not you can do it yourself and where you can find these. And then the lists are the links down below. We have separate lists for the variety of applications. So there's on-road, off-road, and transport refrigeration units that all have lists. Okay. All right, that's all the filter stuff. Let's talk about, that's getting and understanding them and picking the right one. Let's talk a little bit about what to do once you have one of these things on your truck. Now, this maintenance section is going to work both for retrofits and for OEM filters. And again, OEM is original equipment manufacturer. That just means it came from the factory that way. You did not install it afterwards. There's going to be a problem with engine maintenance and filter maintenance. As I said very early on, the addition of a filter to a diesel engine changes the maintenance paradigm because it introduces steps that have to be done that were not there before. So engine maintenance just means making sure you take care of that engine. You have to be more proactive. And by that, I mean for most of our history of engine repair and having internal combustion engines, you essentially wait for something to go wrong before you fix it. And that's still used by a lot of people and a lot of mechanics, but the problem that you have with that, with relation to diesel particulate filters, is that you may not know something's wrong until it's too late. Because a lot of times people will look at the exhaust to determine there's an issue with the engine. And diesel particulate filters are specifically designed to clean the exhaust. So you lose one of your visual cues that there's something wrong with the way the engine is running. You also should be keeping the engine in its original configuration. Watch the fuel usage and don't consume too much lubricating oil. Let's take a closer look at all of these. Do not change the original engine certification configuration. So here's the deal. This is one of the reasons I talked about aftermarket parts, unless you're just replacing. There are a lot of people that like to soup up their engines. They like to chrome their engines up. They like to do all kinds of high flow systems on these things. And the issue with that is, in relation to filtration systems, is that especially if you have an OEM one, if you change anything or any way that the engine was designed from the factory, you're changing the way that engine works in some manner that could have a negative effect on the filter. So be wary of that. You know, things like changing your injection timing or changing the turbocharger settings or increasing the fuel pressure. Those are all things that could possibly provide you better fuel economy and more power But the reverse of that is that because they are different than the way the engine was designed to operate from the factory, they will have an impact on the downstream filter. And it's not always, hardly ever going to be a good impact. Now, as far as fuel usage, if you're using too much fuel or not enough, they both can cause issues with filtration systems. Using too much fuel, that's obviously, I think, fairly simple to understand, because if you're putting more fuel into the engine than it can actually burn, you're going to create more soot. You're going to create more problems that the filter has to take care of. And the more problems you create that way, the more likely it is that you're not going to have a good time with that particular piece of equipment. You could have these increased PM emissions coming from a restricted airflow. That's going to reduce the amount of air, so it's, by that very nature, is going to increase the amount of fuel available. You could have leaking injectors. The injectors are very finely, milled pieces of equipment, and they do wear. And when they get to the point where they're worn, beyond a certain point, they will have a negative impact on the combustion. Defective turbochargers, coolant leaks, all these things can have a negative impact on the fueling of a system. One thing that you do have in your, hopefully, in your back pocket as far as a tool is concerned, maybe I should use the analogy tool belt. You've got another tool that you can use in your tool belt for maintaining your engine. And that's something called an oil test. Now, an oil test is nothing more than taking a sample of the engine oil to a laboratory that will give you a breakdown of the components that are in, and the contaminants that are in that oil. Here's a sample analysis report, which tells us how much water, oxidation, nitration, sulfation, so on and so forth that is happening with this engine. Why is that important, and how does it help me? Because if I know that there's water in the oil, you could have a head gasket leak. There should not be water in the oil. So there's possibly an issue there. If I have, let's see, what's another one? Oh, glycol. If I have glycol in the oil, glycol is coolant. Now, why would you have engine coolant in the oil? You shouldn't. That means that there's a leak somewhere, a gasket broken. And the problem with glycol in the oil is that it doesn't burn very well. It actually would create a lot more soot than normal. So you could have a problem with that damage in your filter. Let's get to the basic oil use, though, because the most common issue associated with failures of filters is consumption or overconsumption of engine oil, because the engine oil is not really designed to burn. It will have a tendency to produce more soot. The more engine oil you burn, the more soot your engine produces, and it also is something that will eventually gum up a filter pretty bad. So you don't want to do this. Now, some of the causes are listed here, hydraulic injectors, turbochargers, valve guides, piston rings. These are all engine components that when they start to wear, it causes excess oil consumption. Your job, if you want to keep the filter happy, is to monitor all these oil consumption events. Check the oil more often. Check the fuel color when the tank is near empty. Check the fuel filter. Those are both things that are going to tell you whether or not the engine is actually running properly and burning too much oil. So we also have another maintenance issue that's related to the filter and not the engine. That's why I said earlier that the addition of a filter changes the maintenance paradigm with these diesel engines, because before filtration, we didn't have to worry about the exhaust so much. We could look at the engine, we could look at what color the exhaust was, but we didn't have anything in the downstream that we really had to take care of. It's just a pipe, right? But that filter now becomes something that we have to take care of. So the filter will have a tendency to build up ash. That's why I put this picture of the charcoal. So over time, there will be components in the exhaust that came from the engine that don't actually burn. And so when your filter goes through a regeneration, they stay behind. The carbon burns off, but the impurities stay behind, and they will have a tendency to build up over time inside that filter. Once you get too much of that, you basically have to get rid of the ash as well. And the only way to do that is to take the filter core off the engine and clean it out. That's called periodic ash removal. This is different and separate from regeneration, because the core of that filter has to be taken off for cleaning. How often you do this depends entirely upon how you use the engine and how well you maintain that engine. So the methods are not all the same. Not all filters, if each filter manufacturer is going to have a different way that they want you to clean their filters. Some of them will make you use air pressure, some will say temperature, some actually, I know this says using water will destroy the filter. That's not exactly true anymore, because there is one process that uses soapy water actually, and it's actually a fairly good process. But it is something that you have to be careful about. When you take a filter core in to be cleaned, and again, this will work for either retrofits or OEM filter cores. Whoever you're having clean this, make sure that they do a baseline measurement of that core before and after they do the cleaning. It should actually have a different weight after it's done being cleaned than it does before, because they're removing ash from that unit. So it should weigh less after. Here's a couple of examples of the kind of devices that are used to clean filtration systems. The one on the left is a Donaldson bake unit, and this uses strictly nothing more than heat to remove the soot from that particular filter core. It's actually pretty passive, because you put the core, you surround it with that blanket that's shown, that's a thermal blanket, and then you put it over this hole, and then you close the door and you turn it on, and the temperature starts going up there, and all that happens to remove the soot is that the core of the filter will heat up, and it will actually cause the pores of the filter to open, and the ash just kind of drops out into that hazardous waste container on the bottom. The one on the right is a little bit more active in that it uses suction and an air hose to basically force the ash out of the unit itself, and it uses a HEPA filter collection device to make sure that the small stuff is all collected. How often should you be doing this? Well, there's lots of different answers. You could do it once a year. You could do it every 2,000 operating hours, every 54 or 50,000 miles. There is no one answer. It's based a lot upon how you use the vehicle. If you use it for a lot of construction, where it's in a dusty environment, you're going to have to clean the filter out more than if you didn't work in that type of situation. But one of the better methods that I've seen is just to pay attention to how much of the oil you're burning. And every 24 quarts of oil, if you're using the right kind of oil, is what the industry standard is. And I mentioned CJ4 oil. CJ4 is a specifically formulated type of oil that does not have heavy metal in it, and it's produced and manufactured to reduce the production of ash by regenerating a filter. So you can use more of it than standard oil. But still, these are the two measurements that you'd want to look at if you were trying to figure out when to regenerate and clean the ash out. Clean the ash out of your filter. Once you do clean that ash out, or have it cleaned out by somebody else, you need to understand that ash is considered a hazardous waste in the state of California, and most states that deal with this. It's either hazardous material, or you have to test it to prove that it's not hazardous. And for most people, doing that testing is not going to work, because the test actually can cost as much or more than the disposal. So if you have questions about that, like storage and disposal, I'm not high on the list of understanding all the rules and regs around toxic materials, but we do have a whole agency called the Department of Toxic Substances Control that regulates the disposal of these kind of materials, and they should easily be able to help you figure any of that kind of problem out if you have that issue. Now, there is the possibility that you may want to do what's called component swapping. Here's the problem. I just ran into this the other day. Let's say you have a fleet of vehicles and you have filters in all these vehicles, and you want to actually make sure that they're operating as often and as much as possible. So when these things have their core filter taken out, and legally you have to park them because that filter's got to be in there in order to run the thing, you might want to have an extra core sitting on the bench somewhere that you can just pop in and then send the vehicle and its engine on its way, and then take the core that you took out of it, clean it, and then get it ready for the next vehicle that came in. That's called filter swapping. And it's perfectly legal as long as the manufacturer has an agreement with the company, with ARB, to do this swapping. And the swapping agreements are only necessary for retrofit filters. If you have filters that are OEM, it's not swapping anymore because that's just the part number that you replace. So that's perfectly legal to do with those guys. As long as they're the same part number, there's no issue there. How about if you have a truck that you want to take a filter off to put on another truck? This has come up a few times. That's something entirely different. That's called redesignation. And the problem with redesignation is that when you decide that you want to put it on a different truck, you have to go through the same process that we talked about going through initially. It's as if you didn't even install that filter once. You have to, put it through the pre-installation compatibility test. You've got to make sure you have an appropriate installer. The filter itself has to be cleaned out and made sure that it still all works properly.